Now, my favorite part is this: application, using the systems of equations to solve real world problems. This is again an extension of lesson 3, but really I'm calling it 3C because it's the third part. If you're writing equations from a problem that they've given you, it's important to identify the slope and the y-intercept. Now, the slope is always the rate, miles per hour, dollars per mile, beats per minute, and the y-intercept is what you get when x is 0. So it's like the starting point, or what we've been calling the initial value. When you go to solve them, you're going to solve them by graphing, just like we've been doing before. And if you're interpreting solutions, it's important to do this: read the question. Where's the question word? Who, what, where, when, why? And then read what it's actually asking you to do. And then pay attention to what the variables x and y represent. X is always the independent variable, while y depends on x, and it's the effect. So how much money you end up spending because you have bought X number of paper clips. Who's buying paper clips one at a time? I don't know. Anywho, the point of intersection is the solution where both of the situations are equal. And then if you're not going to be using a calculator and you're doing it by hand, make sure you graph very neatly and label both your axes. So here's our first example. Yellow Cab Company charges just 25 cents a mile, but it costs $5 to get into the cab. So our rate, 25 cents a mile, is going to be our slope. And our 0, if I go 0 miles, how much is it going to cost me? It's $5 to get into the cab. So my equation is y equals 0.25x plus 5. Whereas the express cab charges no fee up front. So it's going to cost us $0 at 0 miles. But you're going to end up having to pay $1.50 per mile. So y equals 150x, and then I don't add anything else to it. It's just a charge per mile. So the length of the drive is important, because if you're just going a short distance, like a mile or two, it might be better to be in this cab because it doesn't cost you anything to get in. But if you're going to be going a long distance, it might be better to get into a Yellow Cab Company cab, because it's going to cost you $5 upfront to get in, but you can go a lot farther for cheaper money. So if you're going 7 miles, which one should be your call? That means I need to actually substitute in 7 for both of them. And when we substitute in the 7 miles, we notice that for Yellow Cab, it's going to cost me $6.25, and then for Express Cab, it's going to cost me $10.50. So if I'm going to be going 7 miles, I really should be calling the Yellow Cab Company. Now, if I'm only going to be going 3 miles, let's do that one over here. Then it's going to flip-flop which one I choose, because since I'm going such a short distance, that $5 upfront fee has made Yellow Cab more expensive. But since I don't have a fee upfront and I'm going such a short distance, then the Express Cab is only going to be $4.50. So I would choose to ride in Express. So when it's asking what length would make it equal, I'm going to type both of those into the calculator. Y equals 0.25x, or my Y1, plus 5, and Y2 is 150x. And then I do the whole graph it, find the intersect, zoom fit, etc. And I end up with 4, 6. And if we're interpreting what that actually means, at 4 miles, it's going to be $6 no matter which cab you choose. So for Yellow Cab, if you go 4 miles, it will cost you $6. And for Express Cab, if you go 4 miles, it will cost you $6. This is where those graphs intersect, and that's the solution to these two systems of equations. Here's another example. It asks us to graph each pair of equations. Since it's not providing a graph, we're going to use the calculator again. Oh, that's an ugly L. In order to graph and find the solution to the systems of equations. Ashley and Emma are reading the same article. Ashley's on page 1, but she can read a page every minute. Emma's already on page 5, but reads a page every 3 minutes. So what page is Ashley on after 5 minutes? Well, Ashley can read 1 page per minute. She's reading for 5 minutes, and we can already add the 1 page that she has already finished. And that gives me 6. So after 5 minutes, she should have finished 6 pages of the article. If we're figuring out what equations can be used to represent the amounts, we kind of already have one for Ashley. To figure out how many she will read after a certain number of minutes, it's 1 page every minute plus the 1 page that she has already read. And for Emma's already on page 5, so I know that my initial starting point is at +5, so at 0 minutes she's at 5. But she only reads a page every 3 minutes, and that's a rate of 1 for every 3, so a third of whatever X is. So how many minutes does it take before they've read the same amount? I'm going to plug those into the calculator for my Y1 and my Y2, and I end up with a solution of 6, 7. So how many minutes before Ashley and Emma have read the same amount? 6 minutes, because they both will have read 7 pages. And if you didn't actually try it in the calculator, please do. That way you don't go, I get it, and then get to the quiz and go, I don't know what I'm doing. So, yeah. David and James are at the famous Nathan's Hot Dog Eating Championship on Coney Island in New York on the 4th of July. David was late starting, so James already had 6 hot dogs before David even started eating. So this is important. So James starts at 6 and David starts at 0. From then on, James ate a hot dog every 2 minutes, or you could say he eats, half a hot dog per minute. Well, David stuffed 1 1/4 hot dogs per minute. So David's equation, he starts at 0, but then he is getting 1.25 times the number of minutes, or y equals 1 1/4 of x. Now, this says Nathan, but Nathan is the name of the hot dog place. It's James's equation. James started at 6, and then he eats 1 every 2 minutes, or 1 for every 2 times the number of minutes. Between David and James, who would win the contest if it lasted 12 minutes? Well, the way that we solve that is we say that for David, it's 1.25 times 12 minutes, or I think that's 15 hot dogs. And this is assuming they keep the same pace. For James, it would be half times 12 minutes plus 6, which would be 12 hot dogs. Which means that David would have eaten 15 hot dogs. So he would actually win the contest. Now, how many minutes does it take David to catch up with James is another way of saying, when will they have eaten the same amount of hot dogs? And that's something we're going to plug into our calculator. We can set David's equation as y1 and James's equation as y2. We graph it, we find the point of intersection, and then our point of intersection is 8, 10. Now, that's not what the question's asking. It's not asking for just the point of intersection. We use that to determine how many minutes. Since it's asking for the number of minutes, and the number of minutes is our x value, it would be 8 minutes, and they both would have eaten 10 hot dogs. Number 3, one phone company charges $1 connection fee, so our first phone company. It would be y equals $1 to connect, so that's our startup, our initial value, and 50 cents per minute. And then the second phone company, they charge a connection fee of $5, but it's 25 cents per minute. How long is the phone call that costs the same for both companies, and how much does it cost? I'm going to set that up in my calculator. Y1 is 0.5x plus 1. That's our first phone company. And our second phone company is Y2, which is 0.25x plus 5. And I get a coordinate of 16,9. So how long is the phone call? The phone call would be 16 minutes, and it would cost us $9. Now, again, it's important to make sure you know how to graph these in the calculator. It's not enough to just write down the answers I'm getting. Have you tried it in the calculator? Are you getting the same answers? Because if not, then that's something we need to talk about as a class. So check it in the calculator and make sure you're getting the same coordinates I am for these problems.